All right, so your practice questions were numbers 7 to 14 on page 654, 655. Number 7 says, the radioactive nucleus indicated in each equation disintegrates by emitting a positron. Complete each nuclear equation. So 7A is sodium 21. And it tells us that it's emitting a positron, so a 1E. And if it emits a positron, it also has to emit a positive or a neutrino, a regular neutrino. So you add the top, one side is 21, the other side has to equal 21. You add the bottom, one side is 11, the other side has to equal 11. You look at your periodic table and you see this has to be neon. Okay, B is chromium. So Cr, and it's 40, 24, emitting a positron. So this time I'm going to write it as beta, because remember it's positive beta decay, so you could also write it as beta. And a regular neutrino on the top has to be 40. On the bottom has to be 23. Look it up in the periodic table. Valdinium. V. Number 8. Complete the nuclear equations for these transmutations. Okay, and so the first one is phosphorus 30. Phosphorus is 15. And it's going to something where it's giving off a positive beta particle. Top has to be 30, bottom has to be 14. 14 you'll discover is silicon. B, lead 205. And lead is 82. Again, giving off a positive beta particle, a positron, a neutrino. Top has to be 205, bottom has to be 81. Look 81 up, and it's like TL. Yeah, I can't say it. Number 9. Mercury isotope. I'll try to hold this steady while I look over my shoulder to read the book. A mercury isotope, Hg200, is bombarded with deuterons, 2,1Hs. The mercury nucleus absorbs the deuteron and then emits an alpha particle. Okay, so 200 Hg, and it's 80. And it's being bombarded by H2. Okay, so it says it absorbs it and it emits an alpha particle, which we know is a 42H. So on the top over here it's 202, so on the top over here has to be 202, so this must be 198. 81, so this has to be 79. Go to your periodic table and look up 79 and discover, hey, you just created gold. So the first part of the question asks what element was created, gold. And the second part wanted you to actually write out the equation. I think you probably needed to write out the equation before you figured out it was going to give you gold. Number 10. When bombarded by protons, a lithium isotope, Li7, absorbs a proton and then ejects 2 alpha particles. Write the nuclear equation. So it's lithium 7, and on the periodic table lithium is 3. And it says that it absorbs a proton, hydrogen 1, and when it does, it gives out 2 alpha particles. So you could write this as 2 separate particles, so you could put a 2 in front. We know alpha particles are 4 2s. So when we add this side up, it's 8 on the top, 8 on the top. 4 on the bottom, 4 on the bottom, you're done. There's nothing else being emitted here. Number 11 says Find the nuclei given below. Each of the nuclei given below can absorb an alpha particle. Assuming no secondary particles are emitted, complete the equation. So they're just going to take in the alpha particle and not emit anything. So A is nitrogen 14. Okay, and so you're bombarding it with alpha particles. So on the top you get 18, on the bottom you get 9. You look up 9 on the periodic table and find out that it's fluorine. The second one is aluminum, 27 Al, and aluminum is 13. Again, you're shooting alpha particles at it. Takes them in, top becomes 31, the bottom becomes 15. Look up 15 in the periodic table, it's phosphorus. So now, just for the record, like if you're saying, but how are we supposed to know that when it takes in a deuteron and it gives off an alpha particle? You can't. Like, so you would have to be told that in the question. Like, I would never just tell you, okay, ask you what's going to happen. I would tell you what, like maybe one of them, and then make you figure out the other. But I don't expect you to be able to figure it out. It'll take a few more years of particle physics and nuclear physics before that one happens. All right, number 12 says, in each of these reactions, a neutron is absorbed by a nucleus. The nucleus then emits a proton. Complete the equation. See, so it tells you what's going to happen. So the first one is copper, 65. Okay, and copper is 29. So it says a neutron is absorbed, and then it says a proton is emitted. So on the top over here it's 66. So on the top, the total on the product side has to be 66. On the bottom, the total is 29. So the total over here has to be 29, which means this needs to be 28. Look up 28 and find out that it's nickel. B is nitrogen 14 again. So it absorbs a neutron. And it gives out a proton. So top has to be 14, so that both sides are 15. Bottom has to be 6, so the total is 7. Look up 6, find out that it's carbon. Okay, carbon 14. Number 13 says, when a boron isotope is bombarded with neutrons, it absorbs a neutron and then emits an alpha particle. Okay, so so it's boron, and it told us in the question it was boron 10. And it says it's bombarded with neutrons. So you're adding that on the reactant side. And it says when it's bombarded with neutrons, it absorbs them, and then it's going to release an alpha particle. So what must the other thing be? So the total on the top is 11 on the reactant side, so this must be a 7, so it's 11 on the product side. We have 5 over here, so this must be a 3, so we can have 5 on the product side. Look up 3 in the periodic table. This is lithium. All right, and number 14 says, when a boron isotope, boron 11, is bombarded with protons, it absorbs a proton and emits a neutron. Okay, so the first part of this question then, it's boron 11. And it says it's bombarded with protons. And when it is, it absorbs them and releases a neutron. So top is 12, so 11, so the top is 12. Bottom is 6, so this must be 6. That will be carbon 12 for the first, or carbon 11, excuse me, for the first part of the question, not carbon 12. And then the second part of the question says, write that the isotope form decays by emitting a positron. Almost have time to do this. So 11, 6C, and it decays, so you're not adding anything in. Positive beta decay with the neutrino. Top has to be 11, Bottom has to be 6, so that must be 5.